all the pre-existing exceptions are objects defined in exception classes. There's nothing that prevents us from defining our own exception class to do exception processing. However, there are very many exception classes that already exist, and the best advice is to use them whenever you can, whenever they're appropriate. However, if you, for whatever reason, find that the predefined classes won't quite do what you need them to do, then that would be an instance where it would make sense to go ahead and define your own custom exception class. You can do this either by extending exception classes or one of the subclasses from exception. We're going to illustrate making our own custom exception class by extending one of the existing exception classes to suit our invalid radius exception that we talked about earlier. So here we are defining our own exception class called invalid radius exception, and to do it we're going to inherit from exception by extending exception. We have a private double radius member, and it's going to turn out that we don't necessarily need to have that, and we have an alternative implementation that we'll talk about as well following this slide. But we'll leave it in here for now. The next thing we do is we actually construct the exception relying on the parent class exception to do it. So this is the constructor for our invalid radius exception. We know that because it's a method with the same name as the class, and it has a single double argument, which is the radius. What we're going to do is simply call the constructor in our superclass by saying super and then giving the argument, a string argument, which is actually the concatenation of invalid radius with the value of the radius that we're trying to create the circle with. We also turn around and set this data member in here, not to be confused with the data member radius that lives in the actual circle object. This is a separate copy that we're maintaining in here for our own purposes. So we set that radius, or this radius, equal to the radius argument to get that value into our private data member. And then we provide a getter for that so that we could query our exception object at a later time by using its name dot get radius to find out what the radius of the illegal radius was. It'll always be a negative number, of course, if it's an exception object. Now, we don't really need to do all of that. There may be some reason that we want easy access to the numeric value as a number, as a double, rather than just knowing what the number was in string form. However, if it's good enough to simply know what it is in string form, we have that already because the constructor for the superclass has been passed the string invalid radius and then a number. It's not a number, it's not numeric, it's part of a string, but it still represents the same value. And technically we could parse through that string if we wanted to and pull out the numeric value if we needed it for some reason. Also, we can use the getMessage method, which is defined in throwable objects on the exception object, to get that string back at any time. So it's somewhat questionable or debatable about whether or not it makes sense or whether or not it's necessary to have to maintain a numeric value for the radius, if there's any actual advantage in that, and whether or not there's an advantage to producing a getter to access that numeric value. So if you agree that maybe we don't really need to do those things, then in the next slide we'll look at an alternative representation or implementation of this that does not maintain that numeric value. So in this alternate representation, we see that we can remove those particular elements that we talked about earlier, leaving us the code that you see here. So in fact, what you see in this slide now is all that you really need for this implementation. Within the circle class, we're going to have a setter for the radius, and it's going to potentially throw an invalid radius exception, so we declare it that way. The first thing we do is we check to see that the radius is legal, that it's greater than or equal to 0, and if it is, then it's fine to go ahead and set the radius equal to that new radius. Otherwise, we're going to immediately throw a new invalid radius exception, passing in an argument of the new radius. The circle class itself will have two constructors, both shown on this slide. One is a no-arg constructor, which simply calls the other constructor with an argument of double 1. The other constructor accepts a double as an argument, and it's also declared to throw an invalid radius exception. It then calls the setter to set the new radius value, giving the opportunity to generate an exception in the event that the radius is negative. And you'll notice that we still have that counter left over here to indicate how many legal circles were actually made using calls to the circle class. This finally is then the code to test our new circle with our invalid radius exception object that we've created. It has a try and a catch block here. We're going to try to make 3 circles, not unlike what we did before, and also not unlike before. The middle attempt, the second circle that we try to make, is going to have a negative radius. The first circle will be made with no problems, and it won't generate an exception. But when we try to generate that second circle with its negative radius, it is going to throw an exception. When that happens, we're going to abort the rest of the try block and go down to the catch block, where we will indeed be able to catch the invalid radius exception that has in fact been thrown at that point in time. We're then going to do a system out print line of the exception object, and that will show what was wrong with the radius to cause the exception. It will tell us the value of the radius. And then we're going to continue on. After we've done that, we can't create any more circles because we aborted from the try block, but we can continue on through the rest of the program and print the number of objects created. And once again, as we saw last time, we will simply print a 1 for that value because only one circle got successfully created without creating an exception.